The problem I'm working on using my app is about diabetes. Here are the facts. In the United States, there are 37 million people with diabetes, which is about 1 in every 10 people. And about 96 million have prediabetes, which is about 1/3 of the population. Diet control and physical activity has proven to be very effective in keeping the blood sugar level under control. And we also know that different bodies metabolize sugar very differently. The challenge of this problem is that how to have a personalized app that is tailored to individual needs and preferences. So how can database help? It can help in 3 ways. First, by meal planning and tracking. Second, by tracking the blood sugar level over time. And third, by exercise tracking. Shown here is a bar chart of the glycemic index and common high-carb foods. Users can look at this chart and find out immediately what kind of food they should avoid and what kind of food they can take, so they can plan their meal accordingly. And this chart shows the blood sugar level versus the last meal taken right before the measurement. Users can look at this chart and find out quickly what kind of foods are not agreeable to their own bodies and what kind of food are more friendly to their bodies. This is an example to show that will help the users to connect the outcome, which is the blood sugar level, with the controllable variables, that is their personal eating habit and exercise routine. Use this to develop a personalized management plan to keep their blood sugar under control. The first human-centered design feature in my app is the user login screen and the logout button on the main screen. This feature fulfills the needs that users have concerns about their personal data security. For this feature, there's no need for preliminary data. My methods include first creating an authorized user list along with the password and use user authentication, and the main screen is triggered only by valid login credentials. Here is the code. On the login screen, you will see their text input field for username and password. There's action buttons, login, as well as for sign in. When there's mismatch, meaning that the credentials are not valid, there will be an error message. And here is the code in the server file, which does the checking to see whether the credentials were valid. And here is what my login screen looks like. Right now, I include a list of authorized users and their passwords in order for testers to test my app. The second human-centered design feature of my app is the use of clickable menu items for different user purposes. This feature fulfills the needs that different users may have different primary uses for this app. Some use it mainly for meal planning, and some use it for daily blood sugar tracking, while others may use it for exercise tracking. This feature does not require any preliminary data. My methods for this feature is the use of menus, action buttons, icons, and conditional panels. Shown here is the creation of a sidebar with different menu items. Including here is the 4 menu items, including meal planning, blood sugar tracking, exercise tracking, and user feedbacks. Under it, you will see a conditional panel showing that if the user chooses blood sugar tracking, he or she will be asked to enter the data. Similarly, in the output part, each menu item will have a different format of output. For instance, for meal planning, you will have the data table that shows the glycemic index of different foods. For blood sugar tracking, you will see a plot of your blood sugar over time. And here's what it used like after the user logged in. On here, you will see there are different menu items. In addition to the text of each menu item, you will also see icons. The use of icons will help the user who have trouble reading the small text to be able to understand the use of each item very quickly. The third HCD feature of my app is the use of a searchable data table which contains a glycemic index and the glycemic load of common foods for meal planning. This feature fulfills the needs that many users really love to have this information. The data sources I use for this feature including data tables from Harvard University, from the University of Oregon, and other resources on the web. My methods including first load the food glycemic index file and then render data table and color code each food entry based on their categories, whether they are low glycemic index, medium, or high. And then the output should show the data table. This is what it looks like when the user clicks on the menu item meal planning. Here you see that red indicates food that are high in glycemic index or glycemic load. Yellow means medium and gray means low. You may have noticed that the food which is high in glycemic index are not necessarily high in glycemic load. The reason for this is because the glycemic load was actually determined on the actual amount of food you consume, while glycemic index is determined based on 100 grams of carbs in that food. So both types of information are very helpful for the user. The fourth human-centered design feature of my app is the use of persistent data storage. This feature fulfills the needs that most of my users would love to have a longitudinal blood sugar tracking. This makes it necessary for the app to store the data every session so that the user can always come back to check on their blood sugar history and make proper adjustment in their management plan. The data source for this demonstration is synthetic user data I created. In real life, this will be real user data. My methods include first, load the necessary libraries. Because I'm using Google Drive to save the data file, so these libraries are Google Sheets and Google Drive. And then give access to the account and then get the URL of the destination file in which I want to save the user data, and save user data when triggered by a certain event, and then update the data file. And this part of the code shows the libraries, Google Drive and Google Sheets 4, and then give access to the account and also get the URL of the destination file. In this part, the user data was saved into a data frame, and every time when the user click submit, the data is being saved to the data frame. And when the user click done, finished button, and the data file from this session being added to the Google file. This is what it looks like when the user clicked on the blood sugar tracking. On the sidebar, you will see there is data input. First, the date of the measurement, and second, a slide bar showing the blood sugar measurement. The range now is 0 to 500. This sidebar was modified after I talked to my nurse friend who takes care of a lot of diabetic patients. She told me my original max number for blood sugar measurement was too low. I had only 200, and she said some patients can have as high as 500, so I changed it accordingly. My friend also told me medication play a very big part in blood sugar level, so I included the medication list, and the medication list I used here was from University of San Francisco's website. And the user can just click on this user list and pick the medication. And also the user can enter their last meal before the measurement. And when they click submit, the data will be saved for this session. When they click done, all the data will be saved onto the Google file. In the main panel shown here is the user's blood sugar tracking history up to the current session. So you click run. Now I will lead you to walk through the features and this will bring you to the user login screen. Let's log in as user and sign in. Now on the main screen, you will see the menu items. Meal planning, you have a hamburger icon there. For blood sugar tracking, you have a line chart. For exercise tracking, you have a dumbbell, and then for feedbacks. So if you click on meal planning, you will see this data table of different type of foods, and it's color coded. So it's easy for you to see that like white wheat bread, it's pretty bad. If you want to search for certain food, suppose you want to search fruit, you will find a list of fruit with their glycemic index and glycemic load information. The next one is blood sugar tracking. Here you ask to enter the date, which is May 4th. And suppose your blood sugar is 135, no medication, last meal, pasta. And you click submit and click done. And this will be saved onto your Google Drive file, which we can see from here. The last entry is blood sugar 130. Last meal is pasta. So it's been saved here successfully. And here is just the plot of your blood sugar history up to today's session, because I enter many numbers today, so there's a lot of numbers here. There's exercise tracking. In the same way, you enter the date and exercise duration. Suppose you exercise for 1 hour and you did walking. You walk the dog, and you click enter. And on the main panel, you will see congratulations. You have completed your exercise, which is walking the dog for 60 minutes, and you won a virtual medal. And this data also being saved on the Google Drive file. In exercise, you will see the last entry, the user walk the exercise 60 minutes by walking the dog. If you're interested in calculate your calories burned during this exercise, all you need to do is find the meta value for this exercise. Use this table and use this formula to calculate how much calories you have burned. The last item I want to show is the feedback. Here, the user can enter their comments, anything you want to say. Font too small. Submit your comments. And this will save the comments into the user feedback file. Here, the newest entry, font too small. And after you've done everything, you want to log out, you just click log out. That will bring back to the login screen. So that concluded my app demo. Alternative approaches. During the design process, I have considered other ideas. The first one is meal tracking by using images of the food. This is a very attractive feature because during my immersion activity, I have found that food tracking can be very troublesome. But I found this is very hard and I didn't have time to learn and implement it. So I focused on meal planning instead. The second feature I considered is to use audio features to help visually impaired users, which is also very hard and I didn't have time to implement it, so I considered to use icons and also larger font size. But there are some features I can deliver in the near future, which including to expand my food glycemic index data file so it contains both Western and non-Western food so it can benefit more users. And the second one to include larger font size option for elderly users. In conclusion, blood sugar control is the big problem in the United States. There are more than 130 million people who are diabetic or pre-diabetic. Diet control and exercise are effective ways to keep blood sugar under control. In this app, longitudinal blood sugar tracking is combined with meal planning and exercise tracking to assist the users to develop their own personalized diabetes management plan. Therefore, enable them to live a healthier and happier life.